All right, so now we're going to jump into false positives and false negatives. These are most, I guess, around in the term of like testing for things, whether you're testing for strep throat, COVID, the flu, pregnancy, anything where you like take a test. So a false positive refers to when the test result is positive, but you actually are negative. So that's like saying, okay, I take a test, it tells me that I have COVID, and so I stay home and I isolate so I don't get anybody else sick, but actually I don't really have it. I don't have COVID, but my test says I did. Similarly, a false negative is when the test result is negative, but you actually do have whatever it is. So thinking about COVID, same thing. Let's say you feel bad, you take a COVID test, and oh, test is negative. Oh, I must just have a cold. And then you go to your family party and you have COVID and you infect everybody and people die. Yeah. Right? So depending on the test, sometimes a false positive is worse, sometimes a false negative is worse. It just kind of depends on the test. So let's jump into these questions. So a company tested 5,000 people. 96% admit they lie about being sick to get out of work. Assume the test has a 98% accuracy rate and complete the table below. So we're talking more like a lie detector test here. Okay, so these are kind of, I don't want to say difficult. You just got to kind of think through them. So they tested 5,000 people. So that means the absolute total is 5,000. Okay, and then the first thing that we're going to do is we're going to work in this total column over here. So it says, we want to know about like the total number of people that lie about being sick. Well, they say 96% admit they lie about being sick. So that means 96% of 5,000 will have lied. So 96% is 0.96. Of means to multiply. So 96% times 5,000 gives us 4,800. That's how many people out of 5,000 lie about being sick to get out of work. Now, the last thing we're going to look at is if we have 5,000 total and 4,800 lie, that means the other 200 do not lie, which is fabulous. Okay, so our first step is always to figure out the total column. That's where we're going to start. Then we use the accuracy rate. The accuracy rate is what we use to fill in. Oop, too many. Hold up. Nope, oop, oop. Oh my gosh. Oh my gosh. First time. To use the middle 4 here. Okay, so the accuracy rate. Now, this is where I challenge you to use your common sense. All right, work with me here. If, let's say that you are lying, you lie about being sick. So if you take this lie detector test, you would expect to test positive, right? So if you are lying, and we would expect to test positive. So that's the accuracy. That means 98% of 4,800, ooh, that's really ugly looking, of 4,800 do lie. So 0.98 times 4,800 gives me 4,704 that will test positive. Everybody else, so if we had 4,800 and we subtract 4,704, then 96 are going to test negative. Okay, great. Now let's talk about not lying. If you are not lying, then you would expect to test negative, right? So we would say 98% of 200 will test negative, and that gives me 196. So if 200 are total, 196 test negative, that means 4 of them are going to test positive. Then we can just add up the columns. So we have 4,708 and 292. That's how we fill in the table. Okay. And you might say, what does this have to do with false positive, false negative? Well, that's a great question. We're going to get to that. Evidently, we're just going to practice with the tables here for a minute. So let's go ahead. We're going to use this table, create the table again, and then we're going to use that table to find some probability. I recommend you pause, try this table, and then come back and watch the math of it, just to see if you got it. All right, so it's a pandemic. 10,000 people are tested and 32% test positive for the new virus. This test has a 93% accuracy rate. So 10,000 people are tested. 32% test positive that they do have the virus. So we would take 32% times 10,000, and that gives me 3,200 have the new virus. Okay. If I have 10,000 and I subtract the 3,200 that have the virus, then we would expect 6,800 to not have the virus. Okay? All right. Now, thinking about accuracy tests. So when we go to, I need a new color here. Testing positive. If you have the virus, you expect to test positive. So we would say it's 93%. So of the 3,200 who have the virus, 93% is what we would expect to test positive. So 2,976. And then again, we'd say, well, if 3,200 tested positive, that means, if 2,976 tested positive, then 224 will have tested negative. Then we go to our friend not having the virus. So we would expect if you don't have it, you expect to test negative. So 93% of the 6,800 without it. And we would say, where's that number? 6,324. Again, we subtract, there were 6,800, 6,324 tested negative. So that means 476 tested positive. All right, then we add vertically 3,452 and vertically 6,548. All right, so that is, that's the table piece. So now let's use that table. So we have our numbers in the table and we're gonna do this. So the test is positive. This is a conditional probability. If the test is positive, that means we only care about that piece. That means our denominator is 3,452. And what is the probability the person does not have the new virus? Well, that's 476. So you tested positive, 3,452, does not have it, 476, and that gives us a decimal approximation of 0.138. So that's roughly 13.8% of positive tests are wrong. So these are called false positives because it's a positive test, but it's wrong, right? If you do not have it and you test positive, that's wrong. That's kind of how you get there. All right, let's look at letter B. If the test is negative, okay, so now we're just focusing on the negatives. So that means our denominator is 6,548. What is the probability the person does have the virus? So that's 224 over 6,548 for 0.034. So that's roughly 3.4% of negative tests are wrong. And this is called a false negative because you tested negative and it's wrong. That's the idea there. All right, so that's where the false positive, false negative comes into play. All right, you can either be done or we have one more. Feel free again to kind of go through the question and then come back. But the new strain of flu is out. 4,000 people are tested. We know that 1,200 have the flu. Well, if 1,200 have the flu, then 4,000 minus 1,200 gives me 2,800 that do not have the flu. The test for the flu is 94% accurate. So again, remember, the test gives you the number on the inside. So if it's 94% accurate, that means 1200 times 0.94. If we have the flu, we expect to test positive. So that gives me 1128. If I subtract 1200 minus 1128, that gives me 72. And if I do not have the flu, I would expect to test negative. So 2800 times 0.94 gives me 2632. So if I take 2800 not fluers, subtract my negative testers, I end up with 168 positive testers. So that gives me a total of 1,296 that tested positive and 2,704 that tested negative. So now, finding probability. What is the probability of a false positive? Now, a false positive means you test positive, but it's wrong. Okay, so I tested positive, that's 1,296. Which one of those are wrong? Well, if you test positive and you don't have it, that's where it's wrong. So 168. That gives me a decimal approximation of about 1.130. 13% of positive testers do not have the flu. That's what that means. The next one down. Let's go the probability of a false negative. That means you test negative, but it's wrong. Okay, so test negative. That's 2704. And if you test negative, you should not have it. So the wrong piece would be 72. So 72 over 2704 is 0.027, which is roughly 2.7%. So if you would test negative, that means 2.7% of the people who test negative actually do have the flu. And that is what false positive, false negatives are all about.